we are in section 5 of chapter 6, and we're going to start talking about right triangle trigonometry. We know the definitions of trig functions for any acute angle in standard position on the unit circle, but what about in terms of a right triangle? So we know that the sine is a y value of any point on here, and we filled in our unit circle earlier with x and y values, and those were the sine and cosine. The cosine is the x value, the sine is the y value, and the tangent is the sine divided by cosine. So we didn't put the tangent in there, but we certainly can. And we know if we use SOHCAHTOA, this tells me that the sine is the opposite over the hypotenuse, sine opposite hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. So if you can remember SOHCAHTOA, that's going to help you remember what the trig ratios are. So let's talk about how this works with the unit circle and the trig. So there's our theta, and the x value is how far over this way, and the y value is how far it goes that way. So let's talk about some reciprocal functions. We know that the cotangent of theta is the reciprocal of tan. So that would be the adjacent over the opposite. The secant is the reciprocal of cosine, and so that would be the r over the x, or the hypotenuse over the x. And the cosecant, in this case, would be your r over y. So all 6 of those trig ratios are defined here. So calculating the value of trig ratios in any acute angle. Suppose that in a right triangle, ABCD, angle C is a right triangle. So I'm going to just draw. We're going to say that C is the right angle. So I'm going to put that in there. And we know that, let's go with AB for the other two. And we know that AC is equal to 1. And BC is equal to 3/4. Determine the value of the 6 trig functions for A. Well, the first thing that we need to do is we need to find the hypotenuse. So I'm going to use my friend Pythagoras. 1 squared plus 3/4 squared equals c squared. So I get 1 plus 9/16 gives me c squared, which gives me 25/16 equals c squared. Just putting a common denominator, 16/16 there. Square root, I get 5/4 for my hypotenuse. Now, if I want to determine all of the trig ratios, I'm going to say the sine of A is the opposite over the hypotenuse, so 3/4 over 5/4. Simplifying that gives me 3/5. Then I'm going to do the cosine of that same angle, and that's going to be the adjacent over the hypotenuse, so 1 over 5/4 gives me 4/5. And the tangent of A is going to be the opposite over the adjacent, or 3/4 divided by 1, which gives me 3/4. And then we can do the reciprocal of each of those. So I'm going to say the cotan of A is equal to 4/3. The secant of A is 5/4. And the cosecant of A is 5/3. in the same triangle as above, determine the sine of A. Well, we have the sine of A is 3/5. Let's find the cosine of B. So the cosine of B, if I put my theta there, then the adjacent to that B becomes 3/4, and the hypotenuse becomes 5/4, so I get 3/5 again. So the sine of A and the cosine of B are always going to be equal to each other as long as A and B are complementary, or they have to add up to 90. And that works in right triangles. So let's do the tangent of A. The tangent of A we already found was 3/4. The tangent of B, the opposite and the adjacent, would be the opposite over the adjacent, which ends up being 4/3. What happens there is you get reciprocals of each other because you're doing the same thing. And we know that sine of 90 minus some theta is equal to cosine. That's what we were talking about up here. You get the same answer as long as they're complementary. And the same is true with the cosine. That's the same thing we were talking about. Those two there. So as long as those two are complementary, they are going to give you the same answer. All right. So let's get to, suppose that the sine of theta is 2√3/5 and the angle is in the second quadrant. Find the value of the other 5 trig functions. So let's draw my picture. I always draw a picture. And I know that my sine is going to be the opposite over the hypotenuse. So 2√3 is the opposite. The bottom number is the hypotenuse. Oftentimes kids get confused when they'll say like the sine of theta is equal to 1 or something like that. And it isn't, you don't get two numbers. Well, you can always put it over another other 1 to make the fraction. And then we have to use our friend Pythagoras to get the other number. So I'm going to take 2√3 squared plus b squared equals 5 squared. And I get 4 times 3 plus b squared equals 25. B squared equals 13 square root b equals plus or minus root 13. Now, most of the time in geometry, we got rid of the negative root because we were always worried about negative side lengths and negative angles. But if we're on our unit circle and we're going to the left, this is going to be negative root 13 because it's going to the left. And so now that we have that, we can get all of the trig ratios from that triangle. We know that the sine of theta equals 2√3/5. That was given. The cosine would be the adjacent over the hypotenuse. The tangent of theta would be the opposite over the adjacent. And if we needed to, we could simplify that by rationalizing. And then I'm not going to show them here. If you have troubles with it, we know that the cotangent, the secant, and cosecant are just reciprocals of those numbers. Suppose that, let's go to example 10. Suppose that the sine is x/2 between pi and 3π/2. So we know we are in the third quadrant because that's between pi and 3π/2. And we know that the sine is the opposite over the hypotenuse. And we are to find the other trig functions. So I'm going to say, I'm going to have, right here is our theta, and here's a right angle. So I'm going to say x squared plus b squared equals 2 squared. I get b squared equals 4 minus x squared square root. And I know that it's a negative value 2 because we're going to the left again, so 4 minus x squared. And then let me write some of the trig. I don't think I want to do all of them. I'm going to do the sign they gave us, so I'm going to do the cosine of theta is the adjacent, negative 4 minus x squared over the hypotenuse. I'll do the cotangent. We know the tangent is the opposite over the adjacent, so the cotangent is the adjacent over the opposite. There we go. I think that's enough of those. And we are done with that section, so I'm going to stop there and we're going to do some of that next.